Hello friends, in this problem a rectangle has been given and this rectangle is ABCD, and inside this rectangle we have two circles. This is the bigger circle and this is a smaller circle. Radius of bigger circle is given, this is equals to 1 unit. So this length is 1 unit. Radius of a smaller circle is not known. Let's call this is capital R. So QF is capital R and this is the radius, that is QF. So this is capital R. One side of rectangle is also given and that is CD is equals to 3 unit. So this is the side CD and length of this side is equals to 3 unit. Now we have to find value of R, capital R. This means we have to find what is the radius of a smaller circle. Now these points are point of contact. So basically this bigger circle touches this side AD at point Z. Similarly it touches side DC at point E. And the smaller circle touches side DC at point F, and it also touches side BC at point H. So in other words, I can say this line is a tangent on this circle. Similarly, this line is a tangent on bigger circle as well as a smaller circle, and this line is a tangent on a smaller circle. So let us try to find the radius of a smaller circle. As you know, this length is given, that is CD is equals to 3 unit. So this length is given, this is equals to 3 unit. Now let us connect point P with point Z. Z is the point of contact. So this will be radius and this will be 1 unit. And also this is tangent and this is radius. Tangent and radius are always perpendicular. This means this angle is 90 degree. Now similarly this is also tangent and this is radius, so this angle will be 90 degree. And this is a rectangle, so this angle will be 90 degree. So these three angles are 90 degree. This means this angle is also equal to 90 degree. Now this side and this side both are equal. So this means this is a square. So now I can say PEDZ, that is this one, PEDZ, this is a square. Now we can write length CD, that is this side. I can write this side length is equals to CF, that is this one, plus EF, that is this one, plus ED, that is this one. Now what is ED? ED will be 1 unit because this is a square. So all side will be 1 unit. This means this is 1 unit. Now what about FC? What is this length? Now similar to this situation, if you drop a perpendicular from Q on side BC, then you can say that FCHQ is a square. So this is a square. This means this length is equal to this length is equal to this length is equal to this length, and this length is radius. So this length will be also radius. So FC is equals to capital R and this D is equals to 1. So let us plug this here. CD is given, this is 3 unit, and we have said CF is equals to capital R, and let us leave EF as it is, and this length, that is ED, is 1 unit. So from here I can get EF. EF will be 3 minus 1 minus R, that is 2 minus R. So now I know length EF, that is this length, in terms of capital R. Now let us draw a perpendicular from point Q on this line, that is on PE. So this QM is the perpendicular on this line. Now let us consider this rectangle EFQM. So basically EFQM will be rectangle because this angle is 90 degree, this is perpendicular, this angle is 90 degree, and this is also perpendicular, this angle is 90 degree. So this angle has to be 90 degree. So once again, this means this is a rectangle. Now if this is a rectangle, this means EF is equals to QM or MQ. So now I can say this is, and I can also say this length is equals to this length because in rectangle opposite sides are equal. This means ME is equals to QF. ME is equals to R because this length is equals to R. So this is the radius, so this has to be radius because these are opposite sides of a rectangle. So ME is equals to R. So what will be MQ? MQ is basically equals to EF, and we have already calculated EF. This is 2 minus R. So MQ is equals to 2 minus R. What is PE? So this length PE is basically equal to 1 unit. So what is PM? PM will be 1 minus R because this length is R. So ME is R. So this will be 1 minus R. So now I can say PM is equals to 1 minus R because PM plus ME is equals to 1. So PM is equals to 1 minus ME, but ME is equals to R. So PM is equals to 1 minus R. So now what are the things we know? We know this distance, we know this distance. So this means I can make a right angle triangle here. So let us connect point P and point Q. So centers of two circles. Now if you connect these points, it will also pass through this point, that is point N. Why? Because this is a common point, so you will have a common tangent. So this is a common tangent that is tangent to both circles. This means if you draw a perpendicular on this tangent for this circle, this will pass through the center. That is the rule, that is a theorem. Similarly, for this tangent, if you draw a perpendicular this side, then this will pass through the center. This means P and Q is basically one line. It's a P and Q points are collinear points. We can also write PQ length is basically equals to Pn plus Qn. So this will be Qn. Basically there is a mistake here. This is not R, this is Q. So this is Pn plus Qn. That is this length. Pn is this length and Qn is this length. Pn is what? 1 unit because this is the radius. What is Qn? This is capital R because this is the radius. So PQ is equal to 1 plus capital R. Now I can see this triangle, that is PMQ. This is a right angle triangle because this angle is 90 degree. From construction, we have drawn a perpendicular line from point Q on line PE. So now I can use Pythagoras theorem in this triangle. So I can write PQ square, that is hypotenuse square, equals to this length square, that is PM square, plus QM square or MQ square. Now various lengths are known. PQ we have just calculated, this is equals to 1 plus R. So this is 1 plus R whole square. PM, this length, this is basically 1 minus R because this total is 1 and this is R. So PM is 1 minus R whole square. PM square is 1 minus R whole square. MQ, that is this length. We have calculated earlier, this length is 2 minus R. So this is 2 minus R whole square. Now I can expand this using A minus B whole square and A plus B whole square. So if you have A plus B whole square, this is A square, that is 1 square, plus b square, that is r square, plus 2ab. So 2 times 1 times r, that is 2r. Similarly, I can expand this. Only thing is I will have minus 2r here. I can also expand this. So you have 4 plus r square minus 2 times r, that is minus 4r. Now if you simplify, you will have r square minus 8r plus 4 equals to 0. This is a quadratic equation. This is quadratic in r. So we will have two possible values for r. So I can solve this. So if you have a quadratic equation ax square plus bx plus c equals to 0, root of this equation is given by minus b plus minus a square root b square minus 4ac divided by 2a. So minus b, that is minus of minus 8, that is 8, plus minus a square root b square is 8 square, that is 64, minus 4ac, so 4 times 1 times 1, 4, that is 16. This divided by 2 times 1, so that is 2. So this, if you simplify, this will cancel out and then you will have 4 plus minus 2 root 3. So there are two possible roots. One is 4 plus 2 root 3, another is 4 minus 2 root 3. Now let us consider this length PM. This has to be positive length, that is this is greater than 0. Now if you consider PM was basically 1 minus r. So this length is 1 and this length is r. So PM is 1 minus r. So this means this has to be greater than 0. This means r should be less than 1 unit. So if I consider this one, this radius, this is greater than 1. So I cannot have this possible solution. So I can neglect this root and then I can consider this root because this is less than 1. So in this case, radius of a smaller circle is simply 4 minus 2 root 3. So I hope you like this video, and if you like these videos, please share with your friends, like on my channel and subscribe to my channel. I will see you in the next video. Thank you.